Okay, hopefully now all of you can see my screen. This is the tutorial chapter 3 and 4. So we have here around 52 questions. So I did from question 1 until 10. If you have any question, write on the chat. Okay. So we have questions 3D, 6, 9, 10. Okay, 3D, next 9, 10. 3D. Find the derivative of the following function. Y is equal to 1 minus cos x over 1 plus cos x. 1 plus cos x. Okay, now I will start from question 3D. Question 3D. Question 3D states that you have to find the derivative of y equal 1 minus cos x over 1 plus cos x. And so you need to find dy over dx. So this 1 plus cos x squared, will apply the derivative rule. 1 plus cos x squared. Now 1 plus cos x multiplied by the derivative of 1 minus cos x, which is minus sin x, plus. Now I will take here 1 minus cos x multiplied by the derivative of 1 plus cos x, which is sin x. This one. You can simplify more, you can keep it as it is, okay. The most important thing is to find the derivative. Then the other question is 3D. We have also 6, 9, 10. Also 6, 9, and 10. Question 2i. Question 2i. Question 2i same. Question 2i same. Question 2i is y is equal e to the power x minus 1 over e to the power x plus 1. So dy over dx will be the derivative of e to the power x plus 1 square. Now here e to the x plus 1 multiplied by the derivative of e to the power x minus 1, which is e to the power x, minus e to the power x minus 1 multiplied by the derivative of e to the power x plus 1, which is e to the power x. This one also you can simplify or you can keep it as it is, okay. I think one of the students asked for 3b, if I noticed this one. Here you have to apply the derivative rule. So we have 3D 6. What question 6? 6, if A where A and B find in terms of T. Okay, question number 6. Question number 6, if X is equal to A cos 2T, Y is equal to B sin 2T, then you need, where A and B are constant, you need to find dy over dx. So here you have to apply Hopital rule. This one is equal to dy over dt times dt over dx. So dy over dx is equal dy over dt from here. Sin 2t, the derivative of sin 2t is cos 2t times 2. times 2. Here you keep it in terms of b and a is okay, because you don't need to find b and a. B is a constant. Okay, this one. This one times dt over dx. Here you need to find dx over dt first. Okay, or you can, here you have two options. Either you find dx over dt and change this one, or you can find t in terms of x and then you can find dt over dx. So here I will find dx over dt first. So if I need to find dx over dt, dx over dt is equal to a sine 2t times 2 to a sine. So dt over dx is be 1 over t a sine 2t. This one. So 2 is 2b, or you can simplify or you can keep it. It's okay. Both okay. This is for question number 6. Question number 9. Okay, the one who asked question number 9, the problem for dy over dx and d square y over x square, or the problem for the minimum value. Because dy over dx, I think directly the student who asked for question 9, I think the problem for the minimum and maximum value, maybe, I don't know. Because dx is the dy same, you can find dx. Y is, this is question number 9. Y is x 5 cos x plus 3 sine x. Similar question 10. Question 10 and 9 both are asking for minimum value and maximum value. For dy over dx, I think is okay. You can directly find dy over dx, no problem. Now you need to show that the minimum value is equal to 4 for question number 9, and by same method question number 8. So here if you find dy over dx, because I need this one for the minimum value, dy over dx will be 5 sine x plus 3 cos x. Okay, and you can find also the second one, the second square. Now I need to focus for the minimum value. To find the minimum value, you need to put dy over dx equal to 0, or the maximum value. You have to put dy over dx equal to 0. Equal to 0. When you put dy over dx equal to 0, this one equal to 0, then you can get, after simplification, that tan x is equal to minus 5 over 3. Minus, sorry, no. Minus 3. Tan x equal to minus 3 over 5. Tan x is equal to 3 over 5. Minus 3 over 5. This one. Okay, this is the value of tan x. Now you need to solve this one to find the value of y. You need to find the value of x here. Okay, tan x is equal to 3 minus 3 over 5. You need to find the value of x and then substitute here for this one, and you need to prove that y is equal to 4. Y is equal to 4. Y is equal to 4. And then so at 4, this means that at 4 I have a critical value. Maybe minimum, maybe maximum. To know this one is minimum or maximum, you need to check the second derivative at y. because you will find the second derivative. So you calculate the second derivative at 4. At 4. If it is greater than 0, so you have minimum. If it is less than 0, so you have maximum. This is the idea. Same question 10. Same as question 10. Question 10, you need to prove that you have a maximum and you have a maximum value, or find the maximum, sorry. You need to find where is the maximum. So you have y is sine 2x minus ax. Sine 2x minus ax. So first you will find dy over dx. dy over dx is equal to cos 2x minus ex 2 minus ex. This is the derivative. Make it equal to 0. Then you will find that x is equal to natural logarithm of 2. Okay? Natural logarithm of 2. So this is when x is equal to ln 2. And so at ln 2 you have maximum or minimum. To know it is maximum or minimum, you need to find the second derivative at ln 2. Okay, you will find it's less than 0, so maximum. So then natural logarithm f ln 2 will be equal to minus 0.652. Natural logarithm for minus 0.652. Sorry, you need. So this is the value of x ln. First, dy dx, make it equal to 0. Find the value of x. Substitute here in y to find the value of ln x. This is the value of y. So the function at this value, here, this one here at the point, is less than 0. Is less than 0. So here you have maximum. Here you have maximum. So this is the idea for the minimum and the maximum. This is the idea for the minimum and the maximum. Now check chat again to see the other questions. Six, 9, 2i, 10, 8, 9, 6. We already minimum value maximum. So I think we cover both. 8 was the problem. Question 8. Question 8, if y is equal to natural logarithm, show that sine x. Okay, 8, I can give you the idea. For question 8, you need to find y is equal to natural logarithm 1 plus cos x. So now you need to show that sine x d square y over dx square minus dy over dx equal to 0. You need to prove this one. So here first you need to find dy over dx. You need to calculate this one. And then you need to calculate d square y over dx square, this one, and substitute here. Show that sine x multiplied by d square y over dx square, because you already calculate d square y over dx, minus dy dx. Calculate this one. After calculation, you will find it is equal to 0. It is equal to 0. This is only the. But if you have a problem on the derivative itself, you can ask me. Yeah, because I just give the idea how to solve question 8. But if you have problem for any calculation, dy over dx or d square y over dx square, you can ask again on the chat. Okay, now from question 10 and question 20. From question 10 until question 20. Oh, sorry. 15 Hij. 15 Hij and j. Okay. Okay, 15 H. 15 H, we need to find the integral for sine x plus 2 cos x. 15 H. Integral sine x plus 2 cos x over sine x plus cos x. Cos x dx. Sine x plus 2x over sine x plus cos x dx. Okay. Okay. We need to just integrate. The question asks to just integrate. So this one, I think the simplest way is to change this expression to definition, because sine x plus cos x, this one, if you use definition, you will find it is equal to e to the power x. This one, sine x of plus cos x. And sine x plus 2 cos x, if you use the definition, I think it will be 3 over 2 e to the power x plus e to the power minus x over 2. This one. Using definition, use definition. Okay. So this one, integration, I will change it by using definition. This one, the numerator here is 3 over 2 e to the power x plus e to the power minus x over 2. Plus or over sine x plus cos x with e to the power x. So this one integration will be this with this 3 over 2 plus e to the power x over e to the power x here. So 1 over 2 e to the power minus 2x. I think this one is okay. This one is easy now. You can evaluate this one. Okay, now 15i. 15i. Cos x over 3 sine x minus 2 cos x. I think same idea. This one, same idea. 15i. Integration of cos x over 3 sine x minus 2 cos x dx. Change it by definition. Change the integration by definition. You will find this one equal, using definition, its one will be equal to this one. E to the power 2x plus 1 over e to the power 2x minus 5 dx. Okay. And this one you can part it to this one by definition. Change cos x sine x to plus use definition for sine cos to cos. You will find this expression will equal to this one. Now you can integrate this one. This one is equal to 2 e to the power x over e to the power x minus 5 plus integration 1 e to the power 2x minus 5 dx. This one. So I think now both integration can be, because this one, to calculate this one, use substitution, and to calculate this one, use by parts. This one by part, this one substitution. Substitution. Here you can take this one by u. Okay, then you can use substitution. This one you can use by parts. Choose u, choose this one for uv, choose u is equal to 1 e to the power 2x minus 5 dv equal to dx. And continue and evaluate this one. 15j. 15j. 15j simply, 15j no need to use definition, because 15j 1 over cos square x 1 plus tan x dx, right? This one 15j. So here just only use u, because this one is equal to 1 over cos square is sec square x over 1 plus tan x dx. So just use u is equal to 1 plus tan x. Then du will be equal to sec square x dx. And then you can continue the integral. 17. This file with full solution I will send to you, or maybe on e-learning or WhatsApp. I would say how. 17. Show that 1 plus tan square x over 1 minus tan square x is equal to cos 2x by means of substitution t tan x or otherwise. Okay, to show this one you need to use the identities here. You have to use the identities. 1 plus tan square x. This one identity 1 minus tan square is sec square x. This one is equal to sec square. So with this one, 1 over sec is cos square x plus tan square over sec square. Which is equal to cos square x plus tan square over sec square. Tan is sine square over cos square. And 1 over sec square is cos square. So this one with this one, you have only cos square x plus sine square x. And also from identity, this one is equal to cos 2x. So here you can prove this one. And now use this one to calculate the integration. Because the integration of sec, he asked you to use this one to evaluate sec to x dx. And this one is 1 over cos 2x dx. Right? So cos 2x, now you can substitute it by this one. And then you can continue evaluating the integral. Continue evaluating the integral. Okay, question number 19. E, B, E, F. 19, E, B, F. Okay, 19, E, B, F. Okay, 19 E, B, and F. 19. Sorry. 19B. 19B. B cosh in this one differentiate. B and E and F all are differentiate. Maybe I can choose 19E. B and F same. Okay, 19x shine inverse 1 over x. You need to find the derivative. So dy over dx is equal. I have multiplication of two functions. This function is f, this function is z. So apply the derivative rule. F prime g plus g prime f. So f prime x, the derivative of x is 1. So 1 is times sine inverse 1 over x times or plus x now same. The derivative of sine inverse, I think I need to check the formula for the derivative. The derivative for sine inverse 1 over square root u square plus 1. 1 over. Okay, 1 over u square here, 1 over x square plus 1. This is the derivative of sine inverse. Now I will multiply by the derivative of 1 over x, which is 1 of minus 1 over x squared. So this is dy over dx. Similar BEF, F same. If you take 19f, but here not the product rule. Here is a composite function. Tan inverse 1 minus x over 1 plus x. So dy over dx, check the formula for tan inverse first. 1 over 1 minus u square. Okay, the derivative of tan inverse 1 minus this one square times this one derivative, which is 1 plus x square 1 plus x, the derivative of 1 minus x, which is minus 1, minus 1 minus x, the derivative of 1 plus x is 1. So you can simplify or you can keep it. Now another question, 13, 14e and 14f. 13. For question 13, I think the first part is okay. Because question 13, you need to use definition. You need to use definition to of cos x and sin x to prove this one. So this part is okay. So I will solve only the part that related of integration. So now by definition, you need to prove this one. This one is okay. You have to use definition to prove this one. To prove that this one is equal to cos to x minus sine to x. Okay. Now, then after you prove this one, you need to use it to calculate this one. Cos to x plus sine to x. So this one is become from this one, from the what we proved just now, sine to x dx from 0 to 1. how to prove this one? Use the definition of cos 2x, definition of sin 2x. Just normal calculation. I don't think, but if you still have problem doing it, we can WhatsApp me, so I can solve it for all of you. Okay, because this one need calculation here. 14E and 14F. Okay, here I will give you the idea because 14E and 14F same. For question 14, E and F same. Okay, so I will solve E and F by similar way. 14 14E. How to integrate sine cube theta d theta, right? So this one, sine cube is sine square theta, sine theta d theta. And sine square theta from the identities is cos. Cos minus sine is equal to 1. So this one will be cos square theta minus 1. Sine theta. This. So now use substitution. Use u is equal to cos theta. Then du will be sine theta d theta. So this one will become integration u square minus 1 du. And then you can continue. Similar 14f. But instead of sine cube, cos cube. But similar method. Similar method. 14e and 14f, similar method. 14c and 16. 14c. Cos 2x, sine 3x. Cos 2x, sine 3x. Okay, this one, okay. 14, which 14 BFC. 14C. 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 14C, this one also I will give you the idea. Cos 2x sine 3x dx. Okay, now this one, you will use this identity because you have sine x. We know that sine x cos y equal to 1 over 2 sine y plus x minus sine y minus x. Okay. So I will use this one to, so you have cos 2x sine 3x, that one I need to integrate, will be equal to 1 over 2 sine 5x minus sine here, because here this is y, this is x, so it will be sine minus x. 2x minus 3x is minus x, which is equal 1 over 2 sine 5x plus sine x. So now you can integrate this one. You can doing the integration for this part. This part is easy to integrate. This is the idea of 14c. 14c. Now 15f. 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 15f 1 over x squared. This one direct substitution. 15f. Take the substitution u is equal to 1 over x. 15f is the integration of 1 over x squared sine 1 over x dx. So just use u is equal to 1 over x. Then du will be minus 1 over x squared dx. So this one will be integrate minus du sine u. That's all. Now for 16, prove this one. This one prove it using definition. 16, use definition to prove. Use definition to prove. And then use it to find, I think, 16 idea is using definition to prove. That's all. I will not do it now because need more calculation, but if you need this one by details, I can send it to you by WhatsApp. 16, use definition. Question 16. Okay, now from 20 until 30, write your questions. From 20 until 30. 25, 27, 29b, 30b, 25. 26, 25, 27. Okay, I will start from 27 because this one I think is an exam question before this. I don't know if I remember. Then I will go back for 25. For 27, for 27, y is equal to sine m sine inverse x. And you need to prove that 1 plus x squared d square y over dx square plus x dy dx plus m square y equal to 0. So here, to show that this expression equal to 0, you need to calculate this one and this one and substitute. You need to find dy over dx, which here is sine cosine m sine inverse x multiplied by the derivative inside, which is m as a constant. Derivative of sine inverse, just now I think u square plus 1, if I remember. And then you need to calculate d square y dx square as a multiplication of two functions. Then substitute here and substitute this one here. Normal calculation, you get this one equal to 0. Normal calculation, you get this one equal to 0. This one is a derivative of two function. So you need to derive this one first times this one plus the derivative of this one times this one. And then use the derivative. All the terms will cancel each other. So one will be equal to 0. Here I know that I do quickly because I need to solve a question as much as I can. Okay, for 25, differentiate tan inverse plus tan inverse with respect to x and simplify your answer. Here do normal differentiation. No need to simplify. It's okay. For me, it's okay. No need to simplify. Just you need to differentiate this one. But here as a composite function, not multiplication function, okay? So this part, tan inverse, because I need to check the formula for tan inverse. Tan inverse 1 over 1 minus u square. 1 over 1 minus u square. So 1 1 minus derivative minus u square, which is 4x over 1 plus x square, multiplied by the derivative of this part, which is 1 plus x square, 1 plus x, square root of x is 1 over square root of x. 2 with 2 will cancel each other. Minus 2 square x. The derivative of 1 plus x is 1. So this is the first one. Plus, now the derivative of tan inverse. Derivative of tan inverse, also from the formula, tan inverse is what? Inverse 1 over 1 plus u square. Tan inverse 1 over 1 plus u square. So 1 over 1 4x 1 plus x square times the derivative for this one, which is 1 plus x square, 1 plus x times 2 minus 2x times 1, the derivative of 1 plus x. So this one you can simplify, you can keep it, it's okay for me. Is okay, both is okay. $29, $30, $29B, $29A. Many students asking for $29. Okay, what's the problem for $29? $29A and B. $29, integration of sine inverse by parts. Okay, for $29A, integration sine inverse x dx by parts. Take q is equal to sine inverse x, dv equal dx. Then du, I think integration of sine inverse, integration of sine inverse 1 over square root u square plus 1. So this 1 over 1 x square plus 1 v equal to x. So will be x sine inverse x minus integration x square plus 1 dx. And this one by substitution. Take u equal x square plus 1, then du will be 2x dx. Now 29b. 29b, they already give you how to solve. 29b is sine inverse square root of x over x plus x squared dx. This one they already help you, give you a hint. U is sine inverse x, square root of x. Then du is 1 over square root of x squared is x plus 1 times the derivative of square root of x, which is 1 over 2 square root of x. This one is 1 over 2 x times 1 dx, which is 1 over 2 x plus x squared dx. So here become this integration become 2 du That's all. Integration of 2 integral u du. Then you can complete. This one is already given to you. It's already given to you. 30b same by derivative. 30b by derivative. 30b by derivative same. 30b. All the inverse, cosh inverse, sin inverse, tan inverse, use by parts. Use by parts. All these sine inverse, cosh inverse, sish inverse, all used by parts. I need to evaluate this one from 4 over 5 to 1 dx. So this one used by parts. Take q is equal to sec inverse x. dv is equal to dx. Then here v equal to x. du is equal to the derivative of sec inverse. Derivative of sec inverse. Go for the formula. Sec inverse is what? Minus 1 over u square root minus 1 over x square root I think 1 minus x square. So now continue by parts. Continue by parts. See. 29a already solved. 29a. 29 is only 2 questions. 29 only a and b. So 29a solved, 29b solved both. Okay, now from 30 to 50. From 30 to 50, right here from 30 to 50. Okay, 31, 30. This file I will upload for you and also the recording. I will upload for you both after the class. From 31. Prove that sine inverse. Show that this one. Prove that sine inverse is natural logarithm. This one in chapter 2, not in chapter 3 and 4. Now the derivative, to show that the derivative of sine inverse is equal to 1 over square root x squared plus 1. This one I think we do it in the class, in the lecture note. In the lecture note you can find this one. Okay, first, because the question 31, 4 things. First, sine inverse x equal. To prove this one, we already in chapter 2, this one not included in this exam. So, okay, this one is already proved in chapter 2. Now, to prove that the derivative of sine inverse x is equal to 1 over x squared plus 1, this one you can find it in the lecturer note. You can find 2 proof for this one. Okay. Now you need to evaluate the integral 1 from 8, 1 over x squared minus 2x plus 2. This one you need to complete the square. This one you have to complete the square. So to complete the square, 1 over 2 1 over this one, complete the square. So b squared is 4 over 4, which is 1. So you need to add 1 plus 1. So x minus 1 square plus 1. I think this one, dx. So now take ux minus 1. And you can continue. Take ux minus 1 and then you can continue. Now, last thing in question 31, you need to show that this one, okay, this one, I will complete it here. Because maybe you ask because of this part. We have to prove that the integration of 1 round 1 over 2 is 3 over x squared minus 2x plus 2 dx is equal to 1 from 8, 1 over x squared minus 2x plus 2 dx. You have to prove this one. So if you evaluate this one, you find it equal to what? Using the same substitution, and same method. This one will be equal to, you will completing the square and so on. I think this one will be equal to 3 shine 1. After evaluating from 1 until 2, this one is 3 shine 1. Okay, so by using the natural expression, by using the 3 shine inverse 1, so we'll find it 3 shine inverse 1. So by using the natural logarithm of shine inverse, so this one is 3 natural logarithm 1 plus 2, which is equal to natural logarithm 1 plus square root cube. Okay, what about this one? This one is shine inverse 7. Evaluate this one is shine inverse 7. Shine inverse 7 is equal to natural logarithm of 7 plus 50. If you calculate this one, you will find it's equal to this one. 1 plus square root cube is equal to this one. So the value for this integral is equal to the value for this one. That's all. This is for question 31. This is for question 31. Okay, now for question 32b and 33a. Thirty-two B. Shine. Shine square 3x. This one use identities. This one use the identities. Okay. 32b. Shine square 3x dx. This one by the identities will be equal 1 over 2 cos 2x. So cos 2x here will become 6x because x is 3x minus 1 square. Okay, x. Need to check the identity first. I think without a square, but we have to check the identity first. Okay, about the identity for the cos square, sorry, shine square. Shine square. Dash square. Oh yes, without square. Yes. Yeah. This one no square. This one no square. So now you can complete the integral, no problem. This one just use the identities. So 32b, 33a, and 33a. 33a is direct one. Direct one. You need just substitution. Yeah, 33a. This one we solved similar one on the class. dx over x squared minus 9. Here have problem on the 9. So you need to take x squared, replace it by 9u squared. By 9u squared, so u squared will be x squared over 9. So your substitution 1 over 3x. Take this substitution and solve the question. Take this one and solve the question. So no problem on 33a. 34b df. B34b df. Okay, for b, integration by parts. For b, 34b, same by parts. All sine inverse, cosh inverse, tan inverse by parts. Tan inverse x. Use by parts. Take q is equal to tan inverse x. dv is equal to dx. Then v equal x du. Don't know the integration of tan inverse. I think 1 over 1 minus x squared, if I remember. And then you can continue. For 34, this is b, d same. 34d same, also by parts. Integration of x squared tan inverse x dx, also by parts. Take u is equal to x squared. U is equal, sorry, to tan. Take u is equal to tan, not to x squared. Take u is equal to tan inverse x. Okay. And dv is x squared dx. Then du will be 1 over 1 minus x squared. V is 2x dx. Sorry, x cubed first. We are integrating here. V here, x cubed over 3 over 3. Yes. Okay, so you will get this one will be x cubed over 3 tan inverse x minus integration of x cubed over 3 1 minus x squared dx. Okay, now how we can evaluate this integration? Integration of x cubed 1 over 3 outside 1 minus x squared dx. Take u is 1 minus x squared, then du is minus 2x dx. So here x cubed is x squared x. Okay, x cubed will be x squared x over 1 minus x squared dx. 1 over 3. So now replace it by u, 1 over, so you have minus 2 over 3. X squared is 1 minus u. x squared is 1 minus u. X dx will be replaced by du. Sorry, here. Here, x squared will be 1 minus u. X dx will go for du. 1 over x squared is u. So now this one can be easily integrated. This one can be easily integrated. So this is for 34D. 34D. 34F. 34F, similar. I will give you the substitution for 34F. I will give you the substitution that you have to use. Thirty-four F. 34F integration for dx over x squared 9 minus 4x squared. So here the problem here. I have problem here on 4 and 9. So u will be equal, I need u 9u square equal to 4x squared. This is what I need. So I can make it 1 minus u squared. So 9u squared, then u will be 2 over 3x. This is your substitution. So now dx, du will be 2 over 3 dx. So you have 2 over 3, 3 over 2, 3 over 2 du over x here will be replaced by 3 over 2 u. 9 minus 4x squared. 4x squared will be 9u squared. 9 minus 9u squared. Now 3 with 2, 3 over 2 will cancel each other. So you have du over square root of 9 is 1 over 3 outside. U square 1 minus u squared. This one I think is check inverse or cosh inverse. I don't remember. You need to check this integration. Check the formula if it is, I think check inverse if I'm not mistaken. Okay, 37b. 37b. Find dy over dx. This one derivative. This one normal derivative. 37b. Y squared is equal tan inverse xy minus x squared. So here this one, but implicit because you have y squared, right? You have y squared. So 2y dy over dx. So this one is implicit one. Implicit one. 2y over dy dx. Tan inverse, I think 1 plus xy squared. I think the formula like this. Need to check. Actually, I don't know the formula of tan inverse. Is it correct or not? The derivative of tan inverse. Yes, 1 plus u squared. 1 plus u squared. Okay. So 1 over 1 plus xy squared. Multiplied by xy. This one, first I will derive x and keep y. The derivative of x is 1. So you have y plus, now keep x. The derivative of y is dy over dx minus 2x. So now try to bring this one on one side. Try to simplify and bring this one to one side. This is for 37b. 37b. 40, question 40. If y show that, okay, question 40. 40, same, you have y is sine inverse x plus sine inverse x squared. You need to show that one. Okay, first calculate dy over dx. Sine inverse is, I think the formula of sine inverse is 1 over square root 1 minus x squared plus 2 sine inverse x multiplied by 1 over square root 1 minus x squared. Now d square y over dx squared. The derivative for this one is 1 minus. This one, 1 minus x squared to the power minus 2, which is 1 over x squared. 3 over 2 here as a power function. Minus 1. Minus 1, but I have minus 2x here, so become x. Become x. Plus, because the derivative of minus should be minus 1 over 2, but here I have minus 2x coming from the derivative this one, so minus 2 with minus 2, so we keep x only. Plus this one, 2 sine inverse x. Sorry, this one we have a mistake here. So 2 sine inverse x multiplied for derivative of sine inverse x, which is 1 over x. Now this one is a multiplication of two function, or you can make it as the derivative of one function is okay. So if I make it as a derivative of multiplication of two functions, so I will keep the first one, sine inverse x. Now derive this one, 1 over 1x squared, which is x, similar for this one. Plus 2 over 1 minus x squared, derivative of sine inverse x, which is 1 over 1 minus x squared. Now take this one and this one, substitute for this one. For this expression, you would d square y dx squared minus x dy dx, and prove or show this one is independent of x, means that the value or the evaluation will given you something number, maybe numbers not including any x, should be equal to some numbers not including any x. So this is what we call independent of x. Okay, now from question 40 to 50, do you have any questions? From question 40 to 50. From 40 to 52, sorry, because I think there is 52 question here, right? Forty-one C and D. 41. 41 A and B, same idea. I will solve only one. 41. 41A, derivative of a square minus x square. Okay, this one is equal to sine inverse. Because you need to take the substitution like this one. This is normal. You need to take q square is a square sorry, x squared is equal to a squared. So x will be AU, then u x over a. This is your substitution. So this one now become du is 1 over a dx. 1 over a dx. So you will have dx will be replaced by a du over a square minus x square will be minus a square u square. So a from the square with a outside will cancel each other. So you have du over 1 minus u square. So this one is sine inverse. Sine inverse u, which is sine inverse plus constant, which is sine inverse x over a. Similar the second one, 41b. 42d, the integration of 4x 1 plus x squared tan inverse x. Tan inverse x. We have, okay, 42d, 45b, 42c and d also. Okay, now 42c and the ones 42 for C, you can use what we call it by parts. For C, 42C, use by parts. X sine inverse x over 1 minus x squared dx. Then use by parts. U is equal, can choose U equal to sine inverse x. dv is x over 1 minus x squared dx. Because this one can be integrated by using substitution. And du here is 1 over 1 minus x squared. But this one by parts. So this one by substitution. Take t, for example, is 1 minus x squared. So tt is minus 2x dx. Evaluate this integration and then apply the rule for by parts. Apply the rule for by parts. Okay, the second one, integration 42d, 4x 1 plus x squared tan inverse x dx. This one also you can use the by parts. 42d, same, by parts can be used here. 4x 1 plus x squared tan inverse x dx. So take u is equal to tan inverse x, and take dv is equal to 4x 1 plus x squared dx. Then you can calculate by similar. This one easy integration. This one tan inverse x, you check the formula of the derivative and continue. Same idea. Same idea. 44c and f. 44c and f. Number c, complete the square. 44c, complete the square. This one dx, 2x squared plus 2x plus 5. This one complete the square. Okay, because 4b squared over 4a, you have 4 over 8, 1 over 2. Right, then you have 2. I think you can take 1 over 2 first outside. Maybe easier, don't know. X plus 5 over 2. Okay, so this one, uh, so now this one, or you can complete the square directly also can. Okay, 1 over 2 dx x plus, I think, 1 over 4, choose 1 over 2 square, right? X square plus x plus 1 over 4. Here plus 5 over 2 minus 1 over 4. Or you can complete the square directly from here and then go for normal solution. This one idea is completing the square. This one idea is completing the square. If I just give some tips how to solve. If you need the more details of something is not clear, you can contact me, is okay. Now we have a question 44F. 44F substitution. 44F is substitution. Use substitution for 44F. 44F. Use substitution. This one, e to the power x plus 1 over e to the power 2x dx, right? So take u e to the power x. Then du will be ax dx. So this one will become du over 1 plus u square. I think this one is tan inverse or tan inverse, something like that. Maybe tan inverse, I don't know. Check which formula have this one. I think tan inverse. I think tan inverse. 49, 49. 49. Question 49. Prove that the derivative of tan inverse tan x over 2 is equal to 1 over check square. 1 over check square. The student who asked for 45b, 45b use the identities. For 45b, use the identities. Use the identities for 45b. You can use the identities for cosine inverse. Okay. Now for 49, prove that this one, I think this one direct substitution. For 49, okay, 49 d over dx tan inverse tan x over 2 tan inverse tan x is equal, you need to show that this one is equal to sec x over 2. So you need to evaluate the derivative first. So the derivative of tan inverse, I think 1 over 1 over 1 plus u square. 1 over 1. So u here is tan square. X over 2. Now derivative of tan itself is sec square. The derivative of x over 2 is 1 over 2. 1 over 2. Derivative of tan is sec square. X over 2. Tan inverse is 1 over tangent, yes, okay. Now 1 plus tangent square, I need to check the identities first. Let me check the identities. Because 1 plus 1 minus tangent square is sec square. I think just now we proved this. Because here sec square, this one. Okay, sec square here is this one is 1 over cos square x over 2. This one. Okay. Times 1 over plus tangent square is sine square x over 2 over cos square x over 2. We have 1 over 2 outside. So this one, cos square, when you times it here, become 1 over 2 times 1 over cos square x over 2. Sine square x over 2 over cos square x over 2 will become plus sine square x over 2. Now cos square x over 2, sine square x over 2, it will be from identities is cos x. So this one will be equal 1 over 2 sec x. You can go 50 and 51. I will solve 50 only. 51 by same method. Here I will only 50. Okay. For question 50, question 50 express this one. You have this expression x plus 1 over question 50. X plus 1 over square x square plus 1. You need to make it on the form a d over dx x square plus 1 plus p over square root x square plus 1. So this means if I need to make this expression, this one is equal to this one. X plus 1 is equal to a. The derivative for x square plus 1, 2x plus p. So here I have x here, so 2a will be equal to 1. So 2a is equal to 1 plus 1 plus b, which means that b equal to 1. And from here a is equal to 1 over 2. To 1 over 2. If you take x equal to 0, you have b equal to 1. You have b equal to 1. And you can find a. You can find a. Then use this one to show the derivative, the integration. So you need to use substitution. You will choose substitution from the expression. So this is the idea, because when I integrate x plus 1, x squared plus 1, this one from here will be equal to 1 over 2 d dx x squared plus 1 over x squared plus 1, because a is 1 over 2, b is equal to 1. Now you can separate this integration, the first part, plus 1 over x squared plus 1. This one by substitution, this one is sine inverse x. This is for question 50, similar idea 51. Similar idea 51. You have to find a and b, and then you will substitution method, and you will separate the integrations. Same, exactly. 50 and 51, same. 45, for the student who asked for 45, please use the identity. For question 45. Okay, this one. The student who asked for 45, I think 45b, right? dx over 1 plus cosine inverse x, right? So you need to replace cosine inverse x by or I think you can use also what we call it if you divided this one by sine square. I think I just need to try this one. If you divide it by sine square, so you have 1 over sine, which is cosec square x. First I need to wait. I need to check that the identities first. Or okay, you can also use this method. If you don't like to use the identities, I think you can use this method. Because you have the, this one is cosine. Okay, wait. Okay, wait. Okay, I will multiply both sides by 1 over sine square x over 1 over sine square x plus cosine square x over sine square x. This is another idea, maybe easy from identities. 1 over sine square is cosec square over 1 over sine square here is cosec 1 over is cosec square x plus cotan x square x dx. Now cosec square x from identities here is equal, from the identities, cosec square is equal to cotan x plus cotan square plus 1. Cosec square x, this one cotan square x plus 1, cotan square x dx. Now take u is equal to cotan x. Then du is minus cosec x square dx. And then you can continue. So this is for 45p.